As we understand that there are different kinds of data such as integers or float values or characters that we use, this word size allows us to further understand what a range of values a specific data can occupy within the computer's memory. One such data being integer, integers can be defined as whole numbers with a certain range of values, with specific range of values. Now these integers can further be classified as signed numbers and unsigned numbers, or signed integers or unsigned integers. Signed meaning which are the numbers which are represented using sign, which can be positive numbers or negative numbers. Unsigned meanings which the numbers which do not have any specific sign, particularly whole numbers. How much memory can be occupied by an integer type is always dependent on the machine's configuration. Integer type can occupy from 2 bytes to 4 bytes to 8 bytes of memory. Now this always depends on the processor which allocates the memory. A 16-bit processor will usually allocate a 2 bytes of memory for an integer value. A 32-bit processor will allocate 4 byte of memory to an integer value, and a 64-bit processor will allocate 8 bytes of memory for a integer value. As it is known that integers will occupy certain range of values, C language allows us to alter this range by adding certain type modifiers. Now, the type modifiers alters the meaning of a base type uh, to fit into our need more precisely. Now, the modifiers that we can see here are short and long, which are usually preceded before the data type that we use. Now, short here will have the lesser range of values than int, and long has the higher range of values than int. This table represents the kind of modifiers that are used along with the integer type. Here in the table, the first column represents the integer type along with the modifiers like int or signed or shortened or signed shortened or longint or signed longint. The second column represents the number of bits that are occupied in the memory, and the third column represents the range of values. Now, the word size depends on the machine. Uh, it is usually said that the integer data type occupies 2 bytes of data in the computer's memory. 2 bytes meaning 1 byte has 8 bits, 2 bytes has 16 bits of data. Now, when we say bits, it is nothing but a binary digit. A binary value can either be 0 or can be 1. Every information in the computer's memory is stored in the form of a binary value, whether it is an alphabet or a character, uh, or it can be anything. Now coming back to the table here, now as we say that as we can see unsigned int here, now unsigned int has a size of 16 bits, or it can occupy 16 bits of memory, which ranges from 0 to 65,535. Now this is calculated by calculating 2 to the power of 16. 2 raises to 16 will give 65,536. That's the value. So the range of values that you can have is from 2 to the power of 0 to 2 to the power of 16 minus 1, which is usually for sign that we say. So we can have 0 to 65,535 range of values for an unsigned int. For a signed int or for just a normal int, it can be both. It will have the range of values for negative numbers as well as positive numbers. So half of 65,535 will be negative range of values, half of 65,535 will be range of positive values. So the range of negative values for a signed int will be minus 32,768 to 0, and the positive values will be 0 to 32,767. The same holds good for short int, which occupies 8 bits because it will occupy lesser range of values than integer. For long int, it would be 32 bits because it will occupy higher range of values than the integer value. A doubt that may arise uh, while using this integer values and fractional values is, can we assign fractional values to integer type, or can we store fractional values into integer type? Though we might assign a fractional value to integer type, it will not be stored in memory as fractional value, but it will be truncated. That is, all the values after the decimal point will be truncated and will again be stored as an integer value. Having said that, we can always store an integer value by using float data type, but we cannot uh, store a fractional value using an integer data type. A variable is nothing but whose quantity may vary during the program execution. The names that are given to the computer memory location are nothing but the variable names, where we store different constant values such as integer constants or real constants, etc. Now, a constant stored in a location with a particular type of variable name can hold only that type of constant. For example, an integer variable cannot hold float values. An integer variable can store only integer values. Now, the general syntax of variable declaration is type, that is the type of variable, followed by the variable list, where we can have more than one variable in a single statement. Now there are certain rules that are followed while naming the variables and assigning them the values. Now the first rule says that every variable name must begin either with a letter or with an underscore. Now the first example, area, is begin with a letter A, which is a capital letter. We can also use a smaller case letter or a lower case letter while naming. The second example, in second example, uh, area has begin with, or the variable name has begin with underscore, which is also a valid variable name. The next rule says that variables are case sensitive, meaning the lowercase letters and the uppercase letters that are used in variables are completely considered differently. In the example here, the first example, car, we have used all the lowercase letters for the variable name. In the second example, we have used all uppercase letters for variable name. In the third example, we have used the combination of uppercase letters and the lowercase letters. The compiler considers all these three examples as three complete different variable names. Also, we can have variable names that are constructed with digits and letters. We can have a variable name with the combination of these. Also, we cannot use any of the special symbols other than underscore while constructing a variable name. While naming the variables, we cannot be using keywords as variable names. For example, we cannot use main as a variable name or define as a variable name because they are the keywords of C programming language. And also, variable names can